Hello everyone, welcome to Aakruthi, Art of Mathematics, Simple Mathematics classes. This is Relations and Functions, Class 4. I am Sudhir MK. In this class, I am going to discuss about problems on functions. Please subscribe the channel for more video notification. And these problems are from exercise 2.3. Consider first problem. Which of the following relations are functions? Give reasons. If it is a function, determine its domain and range. Now here different relations are given. You have to identify which of the relation is a function. And if it is a function, you have to find its domain and range. Now consider first one. So it is given relation 2, 1, 5, 1, 8, 1, 11, 1, 14, 1 and 17, 1. So function means every element of domain should have unique relation. Now here it is given 2, 1, 5, 1, 8, 1, 11, 1, 14, 1 and 17, 1. That is 2 related to 1, 5 related to 1, 8 related to 1, 11 related to 1, 14 related to 1 and 17 related to 1. Now here all the elements of domain of R have unique relations. That is all the elements of domain have unique image. Therefore the given relation is a function. So here all the elements have only one relation. So therefore this relation is a function. Now here domain. So domain is set of all first element here. It is 2, 5, 8, 11, 14 and 17. So in this relation first elements are 2, 5, 8, 11, 14 and 17. So therefore domain is set 2, 5, 8, 11, 14 and 17. So then we have to find range. So range is set of all second element here. So here second element is only 1. So therefore set containing 1 is the range. So here domain is set of all first element in the order pair and range is set of all second element, and here second element is only 1. So therefore range is set 1. So next, so we see the diagrammatic representation of this problem. So here it is given 2 related to 1, 5 related to 1, 8 related to 1, 11 related to 1, 14 related to 1 and 17 related to 1. So here all the elements have only one relation. So here all the elements have only one relation. So therefore this relation is a function and domain is set of first element here. It is 2, 5, 8, 11, 14, 17 and range is set of images. So here 1 is only image. Therefore image is set containing 1. So next problem. So it is given 2 related to 1, 4 related to 2, 6 related to 3, 8 related to 4, 10 related to 5, 12 related to 6 and 14 related to 7. Now here also it is given 2 related to 1, 4 related to 2, 6 related to 3, 8 related to 4, 10 related to 5, 12 related to 6 and 14 related to 7. Since domain of R having unique images, here all the elements have only one relation. So this relation is also a function. So here this relation is also a function. And domain is set of all first elements. So here first elements are 2, 4, 6, 8, 10, 12 and 14. And second elements are range. So here range is 1, 2, 3, 4, 5, 6 and 7. 1, 2, 3, 4, 5, 6, 7 are range here. So it is set of all images 1, 2, 3, 4, 5, 6, 7. So we see the diagrammatic representation. So it is given R equal to 2, 1, 4, 2, 6, 3, 8, 4, 10, 5. 12, 6 and 14, 7. That is 2 is related to 1, 4 is related to 2, 6 is related to 3, 8 is related to 4, 10 is related to 5, 12 is related to 6 and 14 is related to 7. So here set of all first element is 2, 4, 6, 8, 10, 12 and 14. So that is domain. Set of all images are 1, 2, 3, 4, 5, 6, 7. So that is range. Therefore range is set containing 1, 2, 3, 4, 5, 6 and 7. So next problem, it is given 1 related to 3, 1 related to 5 and 2 related to 5. Now here 1 related to 3 and 1 related to 5, 2 related to 5 and 1 is related with 2 elements. 1 is related with 3 and also 1 is related with 5. So here 1 is related with 2 elements. So therefore this relation is not a function. In function each element should have only one relation. So here 1 is related with 3, 1 is related with 5. So therefore this relation is not a function. This is the diagrammatic representation. So here it is given 1 related to 3, also 1 related with 5 and 2 related to 5. So since 1 is related with 2 elements, so this relation is not a function. So next problem, a function f is defined by f of x is 2x minus 5. Write down the values of f of 0, f of 7 and f of minus 3. Now here question is to find f of 0, that is when x equal to 0 you have to find function value. When x equal to 7 you have to find function value, and x equal to minus 3 you have to find function value. That is to find f of 0, substitute x equal to 0. So here it is given f of x is 2x minus 5. So therefore f of 0 means it is 2 into 0 minus 5. So in place of x you have to substitute 0, and 2 into 0 is 0. 0 minus 5 is minus 5. So answer is minus 5. So therefore f of 0 is minus 5. So next we have to find f of 7. So that is in place of x, substitute 7. So f of 7 is 2 into 7 minus 5. So 7 into 2 is 14. 14 minus 5 is 9. So therefore f of 7 is 9. So next it is f of minus 3. in place of x, you have to substitute minus 3. So therefore f of minus 3 is 2 into minus 3 minus 5. 2 into minus 3 is minus 6. Minus 6 minus 5 is minus 11. So therefore f of minus 3 is minus 11. So therefore f of 0 is minus 5. F of 7 is 9 and f of minus 3 is minus 11. So next problem. If f of x is x square and g of x is 2x plus 1 with two real functions, find f plus g of x, f minus g of x, f into g of x, f by g of x and 3 into f of x. You have to find f plus g of x, f minus g of x, f into g of x, f by g of x and 3 into f of x. So here 3 is a constant. Now we know that f plus g of x can be written as f of x plus g of x. So therefore f plus g of x can be written as f of x plus g of x. Now here it is given f of x is x square and g of x is 2x plus 1. Here we have to add two functions f of x and g of x. So we get x square plus 2x plus 1. So that is f plus g of x. So next question is f minus g of x. So it is f minus g of x can be written as f of x minus g of x. So f minus g of x is f of x minus g of x, and here f of x is x square and g of x is 2x plus 1. And here important, here we have negative, put bracket and write it is x square minus 2x plus 1. So when we simplify, we get x square minus 2x plus into minus is minus 1. Therefore f minus g of x is x square minus 2x minus 1. So next question, it is f into g of x. So f into g of x is f of x into g of x. So here f of x is x square and g of x is 2x plus 1. So therefore f of x into g of x is x square into 2x plus 1. And we can multiply this. X square into 2x is 2x cube and x square into 1 is x square. So therefore f into g of x is 2x cube plus x square. So next problem, it is f by g of x. So you have to find f by g of x. F by g of x can be written as f of x divided by g of x. And here f of x is x square and g of x is 2x plus 1. So therefore f by g of x is x square divided by 2x plus 1. And this function is defined only when denominator is not equal to 0. That is 2x plus 1 should not be equal to 0. That is x is not equal to minus 1 by 2. So here denominator should not be equal to 0. If denominator is 0, then rational function is not defined. That is f of x by g of x is defined only when g of x is not equal to 0. Therefore x is not equal to minus 1 by 2. So next one, it is 3f of x. So it is 3f of x can be written as 3 into f of x. Here 3 is constant, therefore we can take 3 outside. So it is 3 into f of x. So here f of x is x square. So we get 3 into x square. Therefore 3f of x is 3 into x square. So it is 3f of x is 3x square. So next problem. So let f of x is root x and g of x is x be two functions defined over set of non-negative real numbers. Here also we have to find f plus g of x, f minus g of x, f into g of x and f by g of x. Now first we have to find f plus g of x. F plus g of x can be written as f of x plus g of x. Now here f of x is root x and g of x is x. Therefore f plus g of x is root x plus x. So next we have to find f minus g of x. F minus g of x is f of x minus g of x. F of x is root x and g of x is x. So therefore f minus g of x is root x minus x. So next we have to find f into g of x. F into g of x is f of x into g of x, and here f of x is root x, g of x is x. We can multiply this and simplify. So root x can be written as x to the power half and x is x to the power 1. When we multiply this, we get x to the power half plus 1. It is x to the power half plus 1 is x to the power 3 by 2. So therefore f into g of x is x to the power 3 by 2. So next one we have to find f by g of x. F by g of x is f of x divided by g of x. And here f of x is root x and g of x is x. Root x by x can be written as 1 by root x. That is x can be written as root x into root x, and 1 root x cancel, we get 1 by root x. Therefore f by g of x is 1 by root x. 1 by root x can be written as 1 by x to the power half. When you take x to the power half to numerator, we get x to the power minus half. So therefore 1 by root x is x to the power minus half. Here also x is not equal to 0. So here also x is not equal to 0. So therefore f by g of x is x to the power minus half. So next problem. Find the domain and range of the following real functions. So first one, f of x is minus mod x, and second one, f of x is root of 9 minus x square. So domain means what values we can substitute for x, and range is what answers we are getting for the given function. Now here first function is f of x, it is minus mod x. Now here mod x is defined for all the real numbers. Same type, minus of mod x is also defined for every x belongs to R. So we can substitute any value for x. Therefore, domain of the function is set of real numbers. So we can substitute any value for x. Minus mod x is defined for 0, 1, 2, 3 or fractions, or minus 1, minus 2, minus 3 also. Therefore, domain of the function is set of real numbers. And here you have to find range also. We know that mod x is always greater than or equal to 0 for all x belongs to R. But here given function is f of x is minus mod x. Therefore, negative of mod x, we get always negative number and 0. So therefore, we get all negative numbers including 0. Therefore, here range is all the negative number including 0, and we can write it as minus infinity to 0. So it is minus infinity to 0. It is including 0 and all the negative numbers. So that is 0 and all the negative numbers. We can write it as minus infinity to 0. So therefore, domain is set of real numbers and range is set of negative numbers including 0 for the function f of x is minus mod x. So next problem, it is f of x is root of 9 minus x square. So here f of x is root of 9 minus x square, and we know that f of x is defined only when 9 minus x square is positive or 0. If you get root of negative number, then it is imaginary number or it is not defined. So 9 minus x square should not be negative. Therefore, 9 minus x square should be greater than or equal to 0. So that is, we can take x square to this side. We get 9 is greater than or equal to x square, or we can write x square is less than or equal to 9. When x square is less than or equal to 9, so this implies x should be in between minus 3 and plus 3. We can take any numbers from minus 3 to 3. If we take more than 3, we get x square is more than 9. So therefore, x value should be less than or equal to 3. So same type, if we take any value less than minus 3, suppose if we take x equal to minus 4, so then x square equal to 16. 16 is less than or equal to 9. It's not possible. So therefore, minus 4, minus 5, minus 6 and all not possible. So therefore, here domain is only the numbers from minus 3 to 3. So therefore, domain is close bracket minus 3 to 3. That is minus 3 and plus 3 is also included. So next we have to find range of the function. Now when we substitute x equal to 0, we get root 9, and root 9 value is 3. So when we substitute x equal to 3, we get root of 9 minus 9. So root of 9 minus 9 is 0, and root of 0 is 0. If we substitute x equal to minus 3, we get 9 minus 3 square is 9. 9 minus 9 is 0. So again we get root 0. So that is root 0 is 0 only. So therefore highest value we get 3 and least value we get is 0. Here range is from 0 to 3. Least value we are getting is 0 and highest value we are getting is root 9, that is 3 only. So therefore range of the function is from 0 to 3. So all the real numbers from 0 to 3. So next problem, let n be the set of all natural numbers and the relation R be defined on n such that R equal to set of all xy such that y equal to 2x for all xy belongs to n. What is the domain, codomain and range of R? So is this relation is a function. Now here it is given y equal to 2x for all xy belongs to n. We have to check whether this relation is a function. Also we have to find domain, codomain and range of this relation. Now here domain and codomain of the relation is set of natural numbers. Now here we have to take x and y belongs to n. So therefore we have to take all natural numbers. Therefore domain of this relation is set of natural number and codomain is also set of natural numbers. And range, so range is it is y equal to 2x. When we substitute x equal to 1, we get 2. When we substitute x equal to 2, we get 4. When we substitute x equal to 3, we get 6. We get all even natural numbers. Therefore range is set of even natural numbers. So here we get only even natural numbers. So therefore range is set of even natural numbers. Therefore, for this relation y equal to 2x, domain is set of real numbers, codomain is also set of real numbers, and range is set of even natural numbers. Now, since every natural number n has one and only one image, this relation is a function. For every natural number, we get only one image, so therefore this relation is also a function. Since every natural number is related with only one element, this relation is also a function. So we see diagrammatic representation. Now here it is given y equal to 2x, x and y belongs to n. So we can take first set 1, 2, 3, 4, 5, 6, and second set is also natural numbers 1, 2, 3, 4, 5, 6. And here it is given y equal to 2x. So when x equal to 1, we get y equal to 2, that is 1 related to 2. When x equal to 2, we get y equal to 4, that is 2 related to 4. When x equal to 3, we get 2 into 3, 6, that is 3 is related to 6. Since every element is related with unique element, so this relation is a function. So this relation is a function. So next problem, the function t, which maps temperature in degree Celsius into temperature in degree Fahrenheit, is defined by t of c equal to 9c divided by 5 plus 32. Find t of 0, t of minus 10. The value of c when t of c is 212. So here it is given one function which converts temperature in degree Celsius into temperature in degree Fahrenheit. That is t of c is 9c divided by 5 plus 32. So you have to find t of 0. That's temperature in Fahrenheit when temperature in degree Celsius is 0. Now here it is given T of C is 9C divided by 5 plus 32. So first we find T of 0, that is substitute C equal to 0. So we get T of 0 is 9 into 0 divided by 5 plus 32. 9 into 0 divided by 5 is 0. So 0 plus 32 is 32. So we get T of 0 is 32. So that is when temperature in degree Celsius is 0. So we get degree in Fahrenheit is 32. So next problem it is T of minus 10. Here we substitute C equal to minus 10. So T of minus 10 is 9 into minus 10 divided by 5 plus 32. 9 into minus 10 is minus 90. Minus 90 by 5 is minus 18. Minus 18 plus 32 is 14. So T of minus 10 is 14. Therefore temperature is minus degree Celsius implies temperature is 14 degree Fahrenheit. So next one, it is given that T of C equal to 212. That is temperature in degree Fahrenheit is 212. We have to find temperature in degree Celsius. So here it is given T of C is 212. So since T of C is 9C by 5 plus 32, so we can write 9C by 5 plus 32 is 212. So therefore it is 9C by 5 equal to 212 minus 32. Taking 32 to this side, we get 9C by 5 equal to 212 minus 32. 212 minus 32 is 180. So therefore 9C by 5 is 180. Then take 5 and 9 to other side. So we get C equal to 5 into 180 divided by 9. So that is C equal to 100. Therefore when temperature is 212 degree Fahrenheit, so temperature in Celsius is 100 degree. So next problem, let R be the set of real numbers. Define the real function f from R to R by f of x is x plus 10 and sketch the graph of this function. So here given f of x is x plus 10 and we have to draw the graph of this function. So here f of x is x plus 10. It is a real valued function. Since it is a linear function, graph of linear function is always straight line. To draw straight lines, 2 points are enough. So we take y equal to x plus 10. So we take y equal to x plus 10. So substitute x equal to 0. When x equal to 0, we get y equal to 10. So then we substitute y equal to 0. When we substitute y equal to 0, we get x equal to minus 10. When x equal to 0, we get y equal to 10. When y equal to 0, we get x equal to minus 10. So using these 2 points, we can draw the graph. So when x equal to 0, y is 10. When x equal to 0, y is 10. When y equal to 0, x is minus 10. So therefore we get 0, 10 and minus 10, 0. So these 2 points. So draw these 2 points, we get a straight line. This is graph of y equal to x plus 10. So this is graph of the function f of x is x plus 10. So next problem, let f equal to 1, 1, 2, 3, 0, minus 1, minus 1, minus 3 be a linear function from z to z. Find f of x. Now here function is given 1 related to 1, 2 related to 3, 0 related to minus 1 and minus 1 related to minus 3. So you have to find f of x and f of x is a linear function. So since f of x is a linear function, we can take f of x is ax plus b. So since f of x is a linear function, we take f of x is ax plus b. Now here we have to find a value and b value. Now first we substitute x equal to 1. Now here we have to find a and b value. Now here it is given 1, 1 and 0 minus 1 belongs to this relation. So we can substitute x equal to 1 and y is also 1. And when x equal to 0, we get y equal to minus 1. So therefore f of 1. So f of 1 is 1. When x equal to 1, function value also 1. So therefore a into 1 is a plus b equal to 1. Therefore we get a plus b equal to 1. Take that as equation 1. So next substitute x equal to 0. That is f of 0 is a into 0 plus b. So that is a into 0 is 0 only. Plus b equal to minus 1. Here when x equal to 0, we get y value is minus 1. Our function value when x equal to 0 is minus 1. So therefore f of 0 is minus 1. So that is a into 0 is 0 plus b. So we get b equal to minus 1. So we get a plus b equal to 1 and b equal to minus 1. Substitute b equal to minus 1. We get a equal to 2. Substitute b equal to minus 1. Here we get a minus 1 equal to 1. Taking minus 1 to other side, we get a equal to 1 plus 1. So a equal to 2. Therefore here a equal to 2 and b equal to minus 1. Substitute in this function, we get f of x is 2x minus 1. So a value is 2, b value is minus 1. So we get f of x is 2x minus 1. Therefore function f of x is 2x minus 1. So next problem, find the domain of the function f of x is x squared plus 3x plus 5 divided by x squared minus 5x plus 1. So here given function is rational function. Rational function is defined only when denominator is not equal to 0. So here x square minus 5x plus 4 should not be equal to 0. So that is x minus 4 into x minus 1 should not be equal to 0. So here x square minus 5x plus 4 can be written as x minus 4 into x minus 1. So therefore x minus 4 and x minus 1 should not be equal to 0. Therefore x is not equal to 4 and x is not equal to 1. Therefore this function is defined for all real numbers other than 4 and 1. So therefore here domain is set of all real numbers other than 1 and 4. So therefore domain of this function is r minus 1 and 4. That is set of all real numbers other than 1 and 4. The next problem, find the range of the following function. First function, it is f of x is 2 minus 3x when x belongs to R or all x is greater than 0. When we substitute x equal to 0, we get f of 0 is 2 minus 3 into 0, 0. That is, we get 2. That is, when x is nearly equal to 0, we get f of x is nearly equal to 2. So therefore, highest value possible is nearly equal to 2. So when we substitute x equal to 1, we get f of x is 2 minus 3, that is minus 1. If we substitute x equal to 2, we get f of x is 2 minus 3 into 2, it is 2 minus 6, it is minus 4. So we get negative values. So here when we substitute x values more than 0, we get all negative values. Therefore, range of this function is all the numbers less than 2. When we substitute x values nearly equal to 0, we get f of x is nearly equal to 2. Since x value is greater than 0, x equal to 0 is not possible. So we will not get f of x equal to 2. So we get all the real numbers less than 2 only. So, and we can write range of the function f of x is minus infinity to 2. So both are not included. Here range is all the real numbers less than 2. So next problem, f of x is x square plus 2 when x is a real number. Here we substitute x equal to 0, we get f of 0 is 0 square plus 2, so we get 2. So when we substitute x equal to 1, we get 1 square plus 2, it is 3. So when we substitute x equal to 2, we get 2 square 4, 4 plus 2, it is 6. So when we substitute negative numbers, suppose if you substitute x equal to minus 1 square is plus 1. Plus 1 plus 2 is 3. So when we substitute x equal to minus 2, we get 4 plus 2, it is 6. When we substitute any value for x, we get 2 and more than 2. So therefore, range of this function is all the real numbers 2 and more than 2 only. We get all real numbers including 2 and more than 2 only. So therefore, range is from 2 to infinity. So next problem, f of x is x is real number. Here f of x is x, it is a identity function. For identity function, range is set of all real numbers. Here range is set of all real numbers and it can be written as minus infinity to infinity, that is set of all real numbers. Therefore, range of the function f of x is set of all real numbers. It is a identity function. For identity function, range is set of all real numbers. So that's all in this video. Explanation of chapter, relation and function completed. Watch other chapter videos in my YouTube channel, Aakruthi Mathematics Classes. Thank you for watching. Please like, share and subscribe the channel for more video notification. Subscribe my YouTube channel, Aakruthi Mathematics Classes. Thank you once again.